Okay, welcome everybody. How's everybody doing? Good? All right. Any questions before we get started? No questions. Okay, so I assume you're all forming your project teams, right? Maybe picking a project or sending me your ideas on that. I actually started looking at the homework. I'm not done yet, so I have more grading to do, but I will finish that. But thank you for putting those into Blackboard. I'm seeing a lot of them in there, so I'll be grading them. Like I said, I started this weekend, but I got distracted, so I'm going to finish up this week. Any questions on the homeworks, let me know. When I put your grades out there, I'll try to post a sample solution as well. Okay, so yeah, if there's no other questions, we'll just start diving right in. This next section was right where we left off. What we're going to do, so remember we talked about frame diagrams, right? That was kind of an interesting topic, a little bit different probably from what you're used to. Framing the problem before you start trying to solve the problem. Sometimes if you can frame it properly, it may actually allow you to come up with better ways of solving the problem. So if you hear the term reframe, I want to reframe the problem, frame it differently. You probably hear that just in common expressions every now and then. That's done because it sometimes helps us understand it better and therefore be able to solve it more easily. So the reason we break it out into these different domains, we have the machine domain, the application domain, other domains of interest. This is done to try to abstract out some of those details and allow us to focus on how we're supposed to be describing the problem. And that's not from the machine domain, right? We're not describing it in terms of data structures and operating systems and middleware. We're describing it in terms of the real world. That's usually how we write our requirements. If you ever find yourself reading or writing a requirement that seems to be more focused on the machine domain, that means you're probably trying to focus more on how to solve the problem as opposed to how to describe it. So that's something to look out for. We'll talk more about that when we talk about validation. Okay, so having said that, this next section, we're roughly following the SWBOK, the Software Engineering Body of Knowledge, requirements knowledge area. We've talked about most of the main topics in the requirements fundamentals. This next section, we'll talk about requirements process. So I'll talk a little bit about process models. You probably already know about a lot of these, but I'll go over them anyway. And we'll get into actors, support and management, and quality improvement. During that discussion, we'll talk about, and then we'll also move over to elicitation tonight. Requirements elicitation, start talking about some elicitation techniques. We'll probably start talking about use cases, which again, you probably know, but we'll have a quick discussion of that anyway, and start getting into more of the modeling techniques as we get into the requirements analysis. So we're kind of moving from left to right here. That's kind of the approach we're going to take. Okay. Now, process models, if you've had any course at all on software engineering, you're familiar with these. But they are important because it's always, before class, I was upstairs, I was actually documenting a process model for how the software team, my software team, is going to work with the hardware team, the design team in my company, on a hardware software co-design series of steps. Everything is better, it runs better and more efficiently if you can put it to a process model. So what is it? It's a series of steps, like it says there. These steps can be high-level steps or detailed steps. It depends on what you're trying to describe. But it helps orient everybody towards a common goal. So it's kind of a roadmap that if you follow it, you'll at least get somewhat reasonable results. And I'll talk about some that are common in the industry today. Anybody can, these things can apply to anybody, software engineers as well as managers, even your customers and clients. Normally, it's a generic representation, and then what you do always, because you never just have one template that everyone follows with, exactly. You always tailor it. Tailor just means you customize it to your environment. Everyone's different. A large company will do software development differently than a small company in many cases, and so process models can work just as effectively in those different environments, but they'll look a little bit different. And again, we do it mainly to provide stability and control. And when you get out there in the real world, you'll see this. It's pretty obvious when you have an uncontrolled environment. Things are very chaotic. You rely on a couple really smart people to solve all the problems that will inevitably crop up because you didn't plan accordingly. And those few people, those heroes, will probably get paid well. The rest of you will suffer in environments like that generally. But what really happens is the software usually doesn't get delivered to the customer on time, and usually doesn't have the right levels of quality or capability. So it does help. Now, I've spent time in defense industry for many years where you could argue that it was over-processed, meaning it was too heavyweight, there was too much of it. It kind of stifled progress and innovation. And I've also been in the commercial world where it was it was what I call hack and test, a complete free-for-all. Both are not good, right? So we have to try to find something in the middle. The one that seems to be popular amongst a lot of people today is something right in the middle called Agile, and I'll talk a little bit about that as we go through this. We have a section on it a little bit later on, but it provides some process, but it's not over-processed, but it's not completely undisciplined either. And so there's a scale, and we'll have a chance to talk about that. You can apply this to a lot of things. Your software, documents, data, testing. You literally can apply these process models to almost anything you do. Believe it or not, I actually like to apply this. The analogy I use is cooking. I like to cook. Most of my weekends I spend cooking, trying different things, and I get several cooking magazines and stuff, and that's a process model. It walks you through what you need, how to do it, and if you follow that, you usually end up with something that kind of looks like the picture in the magazine, right? You can kind of tell if you're not doing it right. Now, do I always follow that recipe exactly like the magazine? Usually not. I usually, add a little bit more of this, a little bit less of that, if I want to make it a little bit more spicy. So you can always tailor it, to your needs, but generally you have to follow. I'm not going to bake it at twice as long as the recipe says. That wouldn't be right. So you can follow it, you can tailor it, but you generally have to, follow the model, even for cooking or a recipe, something like that. So the steps are various. It does depend on the type of software you're building. If you're designing an aircraft avionics system, in a safety critical device, a website, a mobile device, they're actually all quite different, and different process models will apply to different types of products. Remember we talked about, wicked systems where you don't even know the requirements early on. That wouldn't apply to like a waterfall approach, for example, right, where you assume that you have everything up front. So the steps do vary. And how do you ensure you're right? Well, hopefully you are. There's some measurement that allows you to determine whether you're quote unquote right. What does right mean? It could mean you're delivering, again, the right capability at the right time with the right quality to the right people, to the right customers. So most process models, whatever you follow, there is some measurement that needs to occur in these process models. Actually, if you want to just get a feel for a big part of my day, this is a presentation I'm working on right now. As you can see, I'm just giving you a quick peek at this, but this is from my work. This is all this data. These are metrics that I collect based on the product that I'm developing right now. Okay, all this data, we haven't even put the first release out yet, but the reason you collect this information is you try to manage the process in real time. So you don't wait to the end of a 2-year project and then determine whether your process was right. You collect data every step of the way. We review this. I get this report every Friday morning, and I review it. And if I see things that are out of control or potentially going out of control, I'll call my team and we'll have a discussion on it. So you don't wait to the end. Any process model you develop, you've got to manage it appropriately. Again, you pick the right metrics based on the type of product you're developing, but that's a big part of my day, is making sure that things are in control, looking at metrics, and managing it that way. Okay. So what is a definition then? A framework. Again, it's not an extremely detailed description. It's a framework because you're going to customize it a little bit, and it is a little bit different than what we've been pure software engineering, because that's more technologies. We're talking more about the framework by which we develop those technologies. So any generic process model, if you're going to develop one for work or use one that's out there today, just to give you an idea of what these things kind of look like, a framework, and I'll talk about a couple frameworks like the capability maturity model. If you haven't heard of it, I'll walk you through it very, very quickly. That framework has the basic activities underneath it. Sometimes these can be referred to as umbrella activities. These are all the activities that you need to perform within this framework. Those activities can be broken down into actions, task sets, a lot more detail depending on, again, the type of model that you select. And I'll go over several examples of that with you. But generally, they're eventually broken down to activities that the engineering teams have to follow in order to get the product out the door. One in here, if you can see this, it says quality assurance points. Well, actually, one of the things that you would deliver under quality assurance points during the project would be metrics, which is what I just showed you. Ways of measuring how good your model is working. Okay, as well as all kinds of details about the specific work products and tasks that you need to do, milestones and things like that. Okay. So process flows can vary, and again, I'll go through these. I think you've all are familiar with process models, so I'll go through this fairly quickly, but if you do have a question, if I'm going too fast, just let me know. At a high level, they can be categorized as linear. You're going to go through one phase after another, kind of like in a pipeline approach. For some projects, this works fine, and again, we'll talk about some examples of this. Some are iterative. Okay, they're going to iterate. Anything with a user interface, for example, as a key part of the system we're developing, will probably go through a bunch of iterations. Anything where you need to get something out to the customer very quickly for them to look at will be very iterative. So we'll talk about some of those as well. Again, some projects require more of this, some less. There's evolutionary. Evolutionary is something where, again, you may not know exactly what you're developing, so you're going to evolve it over time. One example of this might be what's called an evolutionary prototype, where you're going to prototype the system to see if the thing can even work, and then as you learn more about that system, you may refine that or evolve that prototype into a final system. Now you have to be very careful about that. You want to be careful that your prototype, which may start off as a throwaway prototype, doesn't change into a evolutionary prototype, because you may skip some steps and you may end up with some poor quality. So you have to make that decision consciously, whether you're going to evolve a prototype or throw it away and start all over. And then at the bottom, there's some parallel process flow. And this one is where you could have literally 2 or 3 different increments being done at the same time. Another example of this is if you're working on a software stack. May look like this. So the simple example I always use is if you're developing a stack of software, a common thing could be the ISO 7-layer stack. You're all familiar with that, from the file layer all the way up to the application layer, and in the middle we have We have the TCP/IP layers 3 and 4. So you can actually have in parallel, people working on different layers of the stack, okay? And that's possible because if you design this stack right or any stack right, the only really thing you have to worry about is whether you've got the API design right. And if that's the case, then you can go through some parallel development activities. Another example is a product that I'm working on. I think you heard me talk about it, I think in this class, this femto base station, where one layer is all the DSP software. This talks to the antenna. This would talk out to your phone, is out here. And this is layer 1, and then we have layer 2. And this right here in the middle, this API, this is a standard called the femto API, FAPI. And if that's designed properly, you can have a team working on the requirements down here and a separate team, which is what we're doing. We're using a completely different company to work on the layer 2 and the layer 3 software. And all we have to do is manage that interface, and we can have parallel development activities going on throughout the project. That's what's meant by that parallel process flow at the bottom, okay? So a lot of that's done in industry today as well. So those are some basic process flows. Now when you're identifying task sets, if you take any one of these and you have to break that down, again, I'm just going to go through this fairly quickly. We're not going to design work breakdown structures or anything like that. But it is important to at least mention this a little bit because each of these key work activities is going to require you to come up with a list of tasks that you need to accomplish, work products that you want to produce, and quality assurance filters. So what does that mean to requirements? So let's say you're in the early phases of your project, and so you're literally in the requirements phase. You're starting to elicit, which we're going to talk about next, or determine what the requirements need to be. What would be some of the tasks, requirements-based tasks, that you would need to do? Okay. Well, actually, there's a lot of tasks that, as a requirements engineer, you would want to do. Some of them we've already talked about, some of them we will talk about, but like tonight we're going to talk a little bit about you have to do a set of elicitation. Actually, even before that, you have to do some planning activities. You have to do some elicitation. You have to do some prioritization, right? Spelled that wrong. You have to do some validation, which is coming up in the course, etc. So there's all, and this is all just for requirements. So there's many tasks you have to plan that deal with just getting, making sure the requirements process is appropriate. And actually, the SWBOC that we're following is actually, a lot of that is based on that process flow. How about work products? What are the work products that would be produced out of the requirements phase? Can you think of any? Some of them are going to be, what are the work products that you might produce out of a requirements phase? Well, we could produce a requirements document. Sometimes they call this a software requirement specification. Tool sets? Yeah. Okay. Tool sets. I mean, as you design, you may also need to look not only at the type of software you have to build, but the different tool sets required to build it. That's actually important to think about up front. As a matter of fact, anyone that's managing a software product early on needs to think about the different tools, the compilers, the testing tools, the automation tools, things like that early on. In some cases, you'll have a separate what's called an interface requirement specification. This just defines, it may define, for example, all your APIs. We have an API book that we do for our, we have a separate API book from the requirement specification. You may produce a whole bunch of models, which we're going to be talking about in the next, going into the next 2 or 3 weeks. We'll be talking about modeling techniques. So there could be some modeling models that get produced. Again, some of this varies based on the process you're following. et cetera, et cetera. So there can be a lot of work products, which ones are important, which ones just, prototypes. Prototypes is a work product that may or may not go to a customer. So there's a lot of work products that may get produced. And then also quality assurance filters. One of the things in a requirements document that is an indicator of how well you've done or how well you understand the problem. If you're reading a requirements document, sorry to keep flipping back and forth, but you may see something like this in the document, right? You know what that means? To be determined, to be done later, yeah. So if you're reading a requirements document, and some of these could be substantial, several hundred pages, and you see a lot of TBDs, what does that tell you? It tells you that you haven't really finished it because we don't really know what these are yet, right? A TBD just means I don't know, I'll figure it out later. Well, sometimes a good metric to use to assess the quality of a requirements document is just simply just to count the number of TBDs and track them over time. Is it going down? Is it getting worse? Is it staying the same? If it's staying the same, that means nobody's closing any of these issues. No one's going out and finding out what these TBDs are. It could be because it's maybe has something to do with performance, and you're trying to understand what the performance levels are, but nobody knows, and so it just drags on. That could be a real problem later on. So there's some quality filters you can apply to the requirements process as well. Okay. So for example, let's just take elicitation. A task set for just elicitation means requirements gathering. Although gathering, I don't like that word. There's a lot of activities that go on. So look at these. Look at this list of 6. You have to understand who the stakeholders are. May be easy, may be difficult, just to find out who the real stakeholders are. You may need to invite them to a meeting. We're going to talk about why you might get your stakeholders together in a meeting in just a second. Ask them to contribute, discuss, prioritize, look at uncertainty. I mean, that's just for the elicitation phase, okay? Now, how about for a bigger project? Now, this might be a simple, yeah, I didn't mention that, simple project. So really something that may just be maybe you're designing a simple iPhone app or a small little utility for your IT department. But how about a big project like maybe working on a software for an aircraft or something large? Now, I put 12 steps on here. Now, the set of steps might be a little bit larger, and some of this may be driven by some of your customers as well. So there's some other things I've thrown in here, like do a better job at identifying constraints and restrictions. There's not many when you have like two-person project, and you want to try to complete something in a couple weeks, but it's not a real big deal whether you meet a deadline or not. Less constraints, but on larger projects where a lot of money is being exchanged, where there's contracts and things like that, there may be a lot more that you have to document here. Methods for validating the system. There's people end up in court all the time in the software business because someone didn't think that they delivered what someone else thought. And sometimes it comes down to simple words like and or in the contract that can make a big difference. One of my colleagues in the software industry has become a expert witness. If you ever want to, if you love being interrogated by lawyers, but also make some decent money, an expert witness, they're in high demand and high tech. So what an expert witness does is that, let's say some company decides to sue another software company, and they need to get an independent party to come in and basically just espouse their expertise and judgment as to whether something may be possible or not possible based on what these people are saying or arguing about. They'll have you come in and testify, and they pay you really good money, but it's a very high stress position because you're basically getting yelled at by lawyers on both sides. So you have to be, but if you're interested in that, become a professional engineer, and get some advanced degrees, and you can eventually become an expert witness. it's not always fun, but it pays well. Okay, so both approaches here produce the same work, but different depth, different formality. Okay, so when you're planning your requirements activities, you know it's not to be taken lightly. There is some discipline that goes into that front end activity. Now, some of the models I'm going to talk about going forward are prescriptive, others are descriptive. Some of the prescriptive models I'll talk about here briefly were originally designed, some of them are old, some are new, but they're all designed really just to bring some order to some, at the time was a very chaotic software development time. So these guys, the prescriptive guys, just like they believe, you know what, follow an orderly approach, you know, a little bit of creativity, but pretty much follow this approach and things will work. Okay, so you've probably heard of some of these, right? Like this one, right? You've all heard of these. This one is already, you know, most people bash this now as a do not do this anymore. When I first started in the industry, we're still doing waterfall, and in defense industries today, people are still kind of doing this. The reason they do it is because you can manage it very effectively. When you have dedicated phases, managers like that because they can tell when something starts, when it ends, and it's easier to manage and get money. In large contracts like in the defense industry, once you finish one phase, you can get paid a certain amount for the project. Then you finish the next phase and you get paid some more. And so it's good for those reasons. But I point out the problems, which most people now understand, right? Software is becoming so complex these days. It's not like the old days where a few tens of thousands of lines of code or even a few 100,000 lines of code. My software release that I make twice a year is about 17 million lines of code. A lot of it's open source, but these are big software systems. It's hard to do these things in a waterfall approach. So there's a lot of, so I point out some problems. Just be familiar with those problems. In many cases, as you know, it's hard to just state all the requirements straight away, straight up front, okay? So sequential now, even when we're doing other forms, like iterative or incremental, we're actually doing kind of mini waterfalls in a sense, but we're just doing many of them, not just one big one. In this particular approach here, when does the customer usually see something? Usually here, right? Way out here. So for a 2-year-old, for a project that goes 2 years, maybe for a complex project that might be a year to 2 years, by the time by the time the customer tells you what they want to when they see something, could be many, many months or years. Okay, that's also not good. A variation of this is this approach called the V model. Really, it's the same kind of waterfall approach down here. So in many ways, it's the same thing. The only thing that gets added to this is a tight mapping to different levels of testing that map to each phase. I actually, as a matter of fact, if you go back to just if you want to know whether this is just theoretical or not, you go back to my presentation that I was showing you earlier. See if I can find it. See this? That's exactly what I'm talking to a customer about later this week. So I'm telling my customer how we're doing different forms of testing at each phase in this V model, and I just walk through the actual data we collect during each phase. Okay, so the V model is real, and it's something that again, it's good because it allows you to just make sure you map different levels of white box and black box testing. If you haven't taken a testing course, don't worry about it, but different forms of testing to each of these phases. So, but for the most part, the development team is still going down the same kind of waterfall approach, but you've got a more direct mapping to a systems testing team, or not a systems testing team, but a testing effort that goes all the way up each level as well. Unit testing, which is white box, all the way up to black box at the acceptance test level. Up here is really where we're going to spend some time in this semester. The requirements approach is normally what the customer uses to do acceptance testing. So we can, in other words, when we hand off a product to a customer, maybe after a system test, and we go to our customer and we say, we're done with all of our testing, all of our tests pass, this system is good to go, please pay me. what they'll probably say is, well, hold on, okay, I believe you, but I'm going to take the system. So up to this point, it's the developer. At this point, the customer says, okay, listen, I'm going to take it out into the field and use it the way I really expect you to use it, not in your simulated lab environment. And I'm going to validate that every requirement that I ask for will work in my environment with real data, real people, real customers. And if that passes, and you can help me, we'll agree on that system test before we do it. And if all that passes, then I'll sign off on the system or pay you that last check or whatever. So there's a type mapping of responsibility when you get into this kind of a V model. Okay. Now incremental is, the way I describe this, it's a lot of mini waterfalls, over and over again, producing more and more capability each increment, right? So with an incremental approach, what you do up front, first of all, you do a little bit of what's called increment planning. And with increment planning, what you do is you decide, okay, how many increments do I want to have? You don't go into an incremental development approach. You don't confuse incremental with iterative. You don't go into an incremental development approach saying, I don't know how many increments, I'm just going to wing it, and eventually I'll stop. Now with increment planning, you actually have an idea of how many increments you want to have, okay? And what you do is you map requirements to those increments. So if I were, for example, collecting some data on this, let me go down and show you this. If I were doing some increment planning, what I might say is I might do something like this. I might say, okay, increment 1 is going to have 12 requirements. Increment 2 is going to have 15 requirements, and increment 3 is going to have 20 requirements. That's how I'm going to split up my requirements into these different increments, okay? So now I've got my work kind of partitioned based on my planning into these increments. Now what you do is over time, each month or each, some amount of time, let's say each month, I'm going to go back and I'm going to look at how we're doing. So let's say this is at the beginning. Let's say out here, I start building my increment 1, and let's say what I really do is I'm able to get 10 of my 12 increments done in increment 1, my push out increment 1, okay? And then let's say over here, for increment 2, I have the 10 increments or 10 requirements that I put out in increment 1, and I was able to do, this is not totally to scale, but I'm able to do 13 increments and 13 requirements in increment 2. Okay? Does this tell you anything? What does this tell you? Yeah, I mean, if I've got 47 total requirements, right? And I said I was going to do 12, but I only did 10. And then the next thing I said I was going to do 15, but I only did 13. So and then so that says that the planning, that means over here I've got to do I've got to do 24 in increment 3 as opposed to 20. But so this is telling me that I'm falling behind, right? It tells me I'm falling behind. And you can start raising some warning bells because, what's the probability? And you hear this a lot from the development team. What's the probability that in increment 3 you're suddenly going to catch up since you've been behind for 2 increments? So it gives you kind of some advanced warning that, hey, you know what? I may have some problems out here. I may have to either have another increment or do something else to catch up, but you can track these things over time. It's an interesting metric to collect, okay? Here's another thing that will help. Okay, let's do this. There's my time, and I'm going to do the waterfall. Let's say with my waterfall approach, I went through my phases like I just showed you. And at that point right there, T1, I deliver something to my customer. My customer gets a chance to see it right there, right? With waterfall, okay? Now, with incremental, same exact project, only now I'm going to do increment 1. And remember, increment 1 is a mini waterfall. I'm going to do increment 2. And then I'm going to do increment 3. And let's say I'm going to finish at the same time T1. Let's just assume that for the moment, okay? Now remember, each increment is like a mini waterfall, right? Okay. So far, so good. Now, with incremental, when does a customer first get a chance to see something? Increment 1, right? They actually get a chance to see it because an increment, when you deliver an increment to a customer, they get a chance to use that in their environment. It's not just some lab thing, demo. It's here's part of the solution, right? So, okay, so that's kind of interesting. They get a chance to see something earlier. If my process was really bad and I had buggy code and or the user interface was really, really bad, when does a user get a chance to comment on it? Way out here, right? What's at this point in time, what do they have to do? What possible recourse do they have? Well, not much. The project's pretty much done. But over here, if the customer doesn't like the interface or the quality is suffering, I get a chance to roll some improvements and changes into increment 2 and fix it earlier rather than, hey, maybe next project. I can do that right away, okay? Okay, now what happens, let's say this was requirements, design, code and unit test, system integration and test. So what happens if this occurs? Right at that point, right here, your boss comes to you or your customer and says, I'm out of money. We have to stop the project. I ran out of money. Okay? In the waterfall approach, at that point right here, what do I have available to me? Really nothing. I've got a bunch of documents. I have some design artifacts. I've got a bunch of code that may or may not unit tested, but I haven't integrated and tested any of it, right? Down here, what do I have available? I've got 2/3 of the product at the customer. They're using it. Okay? Now, if I was planning my increments and I was prioritizing my requirements properly, which we're going to get to, requirements prioritization, and by increment 2, well, the way I would probably plan it is that increment 3 would probably be my low priority requirements, kind of the nice to haves, not terribly important. I'll push those off till last. Why do them early? Do the important stuff early. So then, now if I ran out of money here and I can't get my increment 3, the things that seem to be suffering are the things I probably don't care too much about anyway, right? So there's a lot of benefits to having an incremental approach for all these reasons. So just keep that in mind when you're looking at different. Now again, you may be told by your customer to follow a certain approach, but it's one of the benefits of incremental development approaches. So again, this is kind of saying the same thing. Now with incremental development, again, it says here one slice of the functionality through the whole system. It's not like a horizontal slice where you're delivering increment 1 is a little bit of everything, but nothing really works. It's like, no, here you're going to get end-to-end capability for some of the system. That's what a slice is. Now, it's not too unlike Agile. Agile does the same thing. You deliver slices of the system, and but you do it in a slightly different approach. So you can see this: 1 slice, 2 slices, 3 slices, the whole slice, from interface to the application to any middleware and database. This is assuming a multi-tiered architecture, but nevertheless, that's kind of the approach with incremental. Okay. Now, iterative versus incremental. What's the difference? So they sound similar, right? And iterative versus incremental. If for those of you that are familiar with Agile, Agile is actually more iterative than incremental, right? And really the key differences are the following. You know, you may put out, it kind of says it here, but basically what it says is you may put out something in iteration 1 that is not exactly what the customer wanted, but it might be kind of what they want. You're going to put it out there and ask them to give you feedback. You know, we do this a lot. We're developing new tooling to look at this advanced multi-core processor, and our customer, we want them to look at all this very advanced data, but we're not quite sure what they want to see. So we threw something out there. Not threw. We put something out there, and we had question marks, especially at the user interface, which is normally where you have your question marks, is at the user interface. And we got feedback, and we strengthened it a little bit in iteration 2. And after several iterations, we nailed it. It's like, okay, we all agreed, yep, that's exactly what I want. We gave them an update, and now it's locked. Now let's go on to the second one. So it's more, I don't think I have my picture. Yeah, I have a picture later on. So it's more refining as opposed to these hard slices that you don't change. Does that make sense? So Agile is even, you know, incremental is done to try to get, you know, capability out sooner. But there's still this idea of, with each increment, you know the requirements. You know, like I said, I showed you in that bar chart, you know, you allocate requirements to increments. With iterative, it's even more unknown. But we'll talk more about Agile later in the course, I think later in the course. Okay. And then we have some evolutionary models, and I showed you this one. Prototyping normally, when you work on your project in this class, I think almost every project has a user interface, and we're going to prototype. We're going to talk about that, you know, in the next couple classes. But we're going to develop a low fidelity prototype of a user interface. You don't have to implement it. Some people tend to do that. In the last class, if we have time, we're going to, I haven't told you this yet, but as your last homework assignment, we're going to do class presentations of the projects. And so you'll have a chance to show your prototype. Some people like to create little semi-executable prototypes. Some are hand sketches. Either way, hand sketch is fine. Some people like to do some other fancy things. But when we go through our projects, present our projects, which is usually a fun time, plus you get an extra homework grade out of it, we'll go through and show prototyping, different types of prototyping techniques. But we're going to focus on what's called low fidelity prototyping. There's low fidelity, medium fidelity, and high fidelity prototypes. And we're not going to have to write any code unless you want to. We'll stick with the low fidelity. But basically you start with basic communication, which is always important in engineering. Develop a quick plan, do some modeling. We're going to talk a lot about modeling techniques. Do the prototype, deliver it, get feedback, very important. You don't, one of the mistakes made out in this phase is you deliver a prototype to a customer, and even though the customer doesn't like it, you try to convince them to like it. You're not supposed to be convincing them to like it. You're supposed to be listening to them tell you what they want. People get, sometimes take things personally, this kind of feedback. You shouldn't do that. You should view it as very positive. That's why you also develop a low fidelity prototype. A mistake often made with people developing prototypes is they spend months developing a very high fidelity prototype using, you know, Java or Tcl/Tk, or, you know, make it very flashy. And then when you get out from a customer and they tell you they don't like it, that person gets very defensive, very offended because they spent all this time and effort. But when you're doing it with a paper prototype or a whiteboard, who cares, right? So, and you can still get very, very good feedback with these low fidelity approaches. So the spiral approach, again, I think you all know about this. I think the only thing I'll say about the spiral approach as it relates to requirements is the following. Is anybody not familiar with this approach? So you've all seen the spiral approach? So what are those inner spirals? What do they do? How about that? I mean, yeah, they spiral, but what are they there for? What are we trying to determine in those first few spirals? Because you're not, in those first few spirals, you're not actually developing your product per se. Okay, so you have to read the words in here. So this is where people get a little bit. So see in the middle, it says right here, okay, you're going to do some requirements planning, life cycle planning, but then what do? Risk analysis, and then these things called prototypes, concept of operations, risk analysis, prototype, simulations, models, benchmarks. What does all that mean? What are you trying to do there? Okay, so here's the deal. There's some requirements that you're going to run into where you're not sure if you can actually pull it off, if you can actually implement it without a lot of money or time or effort or something else that blows out one of your constraints. So you're just not sure if you can do it. So what would you rather do? Would you rather say, okay, Mr. Customer, I'm going to give it my best shot, and I'll let you know in 6 months whether I can do this or not after you've spent all your money and time and effort and we both are frustrated? Or here's what I'm going to do. I'm going to identify the top maybe 4 or 5 requirements that I think are very risky. Like, for example, I don't know if I can achieve this level of performance that you're asking me to achieve. Or I don't know whether I can implement this piece of capability that you asked me, because I may not be familiar with the algorithms enough to perform this computation you want me to go off and do. So what these early things are meant to be is, I'm going to go work on that, and I'm going to try to find out as quickly as possible whether I can do it or not. And if I can't do it, I'm going to come and tell you, and right here, we're just going to cancel the project or change the requirement. If I can do it, then I'm going to go off and look, okay, what's the next riskiest requirement? What do I need to do to prove to myself and to my customer that I can do that? And I'm going to keep doing that for some number of iterations. And at some point, out here at the end here, at some point, after these prototypes and simulations and models and research, I'm going to be able to convince myself and my customer that, you know what, I think I can do this project. I can implement your requirements. I've done enough work that I think we can make it. Then you go into this. This is the formal development process that you're familiar with out here. Okay. So all you're doing with this is you're just risk reducing. This is not incremental. This is not another way of showing an incremental approach with each spiral being an incremental. It's completely different. It's risk reducing the key requirements that that you're focusing on that are adding that risk, and then or it could be validating a constraint. For example, if your customer says you have to do this whole project in 3 months, you may have to go off and do a little bit of work and come back and say, no, it'll never happen. I need 6 months or something like that. But you try to determine that quickly so you can shut the project down or make some changes before you get way deep into the development cycle. So that's kind of what this is showing here. Does that make sense? Yeah.
Are we still using this model?
Is this model still being used? Yeah, it is. I think it's morphed. I think Barry Beam was also, see, it says Beam 87, so it's still kind of old. So Barry Beam was a guy who you guys might not know because he's but way back when he was kind of a pioneer in the software engineering industry. He came up with he actually kind of came up with a waterfall model, and then in the mid '80s he realized that that's probably not the right approach. He went back, came up with this spiral approach. He's written a very interesting book that's kind of old now, but it's called Software Engineering Economics. He invented or had a big contribution to the software estimation tool called Kokomo. And he's also, and I may give you something to read, he's also, I think his latest, and I think he's out of University of Southern California, and his latest requirements-based contribution was an approach called win-win, which is getting a requirements solution where you and your customer both have equal benefit. And there's an article I'll post for you on that. So although this is an old model, it's morphed over the last 25 years, and so other approaches like Agile pick up components of this, so iterative techniques kind of follow this approach. not literally, but like in defense, there'll be specific efforts to go off and do a risk reduction before you get into the actual project and stuff like that. So it's used and it's morphed over the years, but still essentially in a way of reducing risk.
But if the customer is not sure that we are going to deliver, then why he will pay for that?
Well, so sometimes they don't. I mean, sometimes this risk, well, so let me ask you, what would a customer, if you're a customer, what would you rather do? Would you rather have your vendor go off and spend 2 years of your money and then tell you very late after all the money's been spent that they can't do it? Or would you rather, almost as an insurance policy, fund them to do a little bit of work to prove that it can be done? Think of it almost like an insurance policy. Now, in some cases, this gets funded by both sides. Some small companies. I met with the CTO of a small company last night for dinner. They'll go off and actually do some of this themselves, and then come into a big company and say, "Look, we've solved that problem. Now, come look at us." Right? That could be a benefit. A lot of people make their money by finding an area or a risk where other people can't solve it and go and solve it, and then people will say, "Oh, that's really cool," and then they'll buy them or invest in them or something like that. So, and then we get the agile, and again, agile we just got through talking about it. Iterative. I'll talk more about this, but anybody out here actually doing any agile-based development? A little bit, okay. Are you guys doing the scrums and all the different components? Okay, so agile development is the newest kind of I guess one of the newer technologies. I don't want to call it a fad, but it's a popular approach, and I kind of like it. We're doing it. We're doing this in several projects in my group as well. It uses some different terminology for requirements. For example, you might be familiar with use cases. They use user stories. We'll talk about that too. Rapid iterations, sometimes a month or less. I'm not sure what you guys do. What are your iterations? 3 months? Yeah, okay. I mean, all this is customizable, right? Scrum is a kind of a daily stand-up meeting where you make quick decisions and you show constant work. And if you get really extreme, you can do other more advanced techniques like test-driven development, which falls under that umbrella, which we can touch on that if you're interested. They have concepts like just-in-time modeling. I'll talk about the whole Agile manifesto, but they don't believe in heavy documentation. They believe in minimizing documentation, and just the product is the work is the code that you and your customers involved every step of the way. A lot of very interesting concepts to this, and we're using this. This can be done. Now, is this good for very large, like defense projects? They haven't really figured out a way of doing it effectively in large projects like that. It's very good for smaller and medium-sized projects. And even the defense industry guys are coming and listening more to Agile because they're trying to do more of this in their area as well. So we'll talk, I think, yeah, we'll talk more about Agile. I've got a whole section on it coming up, and I'll walk you through how to do that and what requirements, things you have to know. And I think I've got a section on user stories coming up as well. So iterative, very iterative, okay? Okay, and as you can see down here, what comes out is not demoware, it's working software that the customer can take and use, kind of like what I was mentioning earlier as well. Now, are there any concerns with these kind of evolutionary processes? After all, at least with waterfall, you knew when you were going to get something, pretty much after you planned it. With these evolutionary approaches, they can get out of hand. I had a guy come up to me. I was one of the guys that worked for me, and I was asking him about a compiler capability. I needed a compiler optimization to be done. This is a true story. To be done for me, a customer wanted this optimization, and he looked at me very, very serious, and he said, "Rob, these things just you can't rush it. This just happens organically. Just kind of happens organically." And I had an open source software manager, and if you've done any open source software development, that type of developer is a little bit different anyway, the open source community. Same kind of comment, well, you know, we don't really have schedules, we just kind of work on things and stuff eventually comes out, okay? That's what happens when you take some of these evolutionary approaches too far and become, you know, then it stops becoming useful because you don't, software unfortunately, can you imagine going to your customer and saying things are organic and you'll get something eventually, but you can't really say when? Usually most customers don't like that very much. Don't say that to them, okay? The point I'm trying to make is sometimes iteration and even increments gets unbounded. When do you stop? When can you tell a customer you're going to stop? I hear this, my boss one time thought Agile, when I was rolling out some Agile pilot projects, he thought it was just a euphemism for not having schedules. You're just doing that so you don't have to give me a schedule. You know, so there's a lot of this, you know, there's a lot of, you know, things that could go wrong if you don't manage this properly. That's why it's always good to have an Agile kind of consultant maybe helping you through the first one or two. Prototyping could lead to an uncertain number of cycles. I mean, one of the things about getting feedback from a customer or a user rather, I guarantee you, if you show your prototype to a large number of people, you will never, ever get a consistent answer. Everybody's going to have a different opinion. And if you keep doing that, you'll never stop. You'll never get, you know, everyone saying, yes, that's it. So you have to know when to stop. If you don't, that could be a big problem, cause delays. Just the speed. If it's too fast, it becomes chaotic. If it's too slow, then again, productivity could be affected. One of the things about evolution, just like, you know, normal evolution, you got to be careful it happens at the right pace. If you put it with each iteration and each increment that you put out, there's overhead. Every time you spin an iteration or an increment, you've got to go through some overhead. That overhead includes, you know, basic management, configuration management, testing, reporting, things like this. Uploading it to a website if you have to do that. You know, when I do a release, you know, we have 2 major releases every year, and then we have a number of, you know, intermediate releases. Each release is a significant amount of time just to manage the release. So the more of these iterations you throw into the process, the more of that overhead you're adding. So don't think it's free to add an increment or an iteration. There's always some overhead that comes with it. So you have to be careful of that. And then software processes focus on flexibility and extensibility, being able to easily extend the software. Sometimes we'll sacrifice quality. I'm not saying always, but at times, and here's the reason why. When you put out an increment, or an iteration rather, let me go back to this. Let me go back to this picture real quick right here. This picture with the question marks. So you put something out and you're not sure if the customer is going to like it, and then they give you feedback, and then you strengthen it a little bit, and then they give you feedback, and you eventually give them what they want. Well, underlying that could mean a lot of what's called refactoring. You could, between each iteration, have to go back and change a lot of infrastructure, architecture, in order to make that work. Like, for example, in a user interface, in a multi-tiered architecture like this, there's actually a pattern that many engineers and architects follow called model view controller, which separates the concerns from the user interface, from the database, and from the application layer or the middleware. And this pattern is a tried and true, you know, approach to doing systems with interfaces and some kind of a data entity. But if you are not keeping some of that in mind, you could get yourself into a lot of refactoring, which could, if you don't do it properly, impact quality. Okay. Again, if you go really extreme to XP, extreme programming, they even will say, don't worry about architecture. You'll deal with that in the next tight iteration. And now I'm not saying that that leads directly to poor quality. It means if you're not trained in how to do refactoring and how to identify the different code smells. A code smell is a bad piece of code that you have to fix. Then the quality could be impacted. So you have to be careful there as well. okay? So there are some concerns. I'm not saying they're bad. I actually use a lot of evolutionary processes myself. I'm just saying you have to be careful how you manage them. This concurrent state model machine, this is we're gonna talk about different types of modeling approaches. Software development can also be almost modeled as a state machine with these different phases and triggers that kind of get you from phase to phase. This one just shows a modeling activity that shows a piece of software that could be under development, awaiting a change, revision. And by the way, software, we're going to talk about this in the back part of the course, but managing the difference like revisions and point releases and stuff like that, and how to manage those from a requirements perspective can get pretty complicated. This state machine, when you're dealing with several revisions, let's say you've got requirements that go into 5 different products. Each of those products has a different cadence for different revisions and releases. How do you manage all that? Well, this state machine between change control, review, baselining, et cetera, can get pretty complicated how you manage that. Again, you want me to show you another example from industry? I'll show you this. Again, I'm just trying to show you, this is real life stuff here, so that's why I'm showing it to you. Okay, you know what this is? You probably don't. It's called frozen. Okay, don't worry about the title. So what this is, this right here, that arrow, and this arrow are 3 configuration management branches of our software. This is our main line. So our latest release, this release is coming up at the end of the year, 1.7. This SDK just stands for Software Development Kit. This is the 17 million lines of code that I was telling you about. So we have a release coming up at the end of the year. But our customer, because of various reasons, these guys are building a base station. They're taking it out and getting it certified with all the Verizons and carriers. They need to have frozen branches. What a frozen branch means is the following. Let's say we gave them this a year ago, and they're taking this into trials with the carriers. They can't be accepting all kinds of changes that were thrown into the software. They have to stabilize that branch and only make fixes when there's a defect. Okay? Whereas we're continuing on. We're making all kinds of changes for other customers and proceeding on. They also need a frozen branch with the release we made 6 months ago for other customers. So now this becomes a management nightmare if you're not careful. That what this means is that I have to manage requirements on 3 different branches of software. And certain requirements changes that may get asked for here, I may have to also go do here and here. If I make a change here, I may have to forward port it here. See how difficult this is? All these arrows that are going all over this page is a management challenge of how we have to deal with potential new requirements coming in and things like this. So that these multiple versions, multiple releases with different requirements for different branches is a really big problem. And so this state machine, how you manage all that, can become very, very difficult. We're going to talk about this more towards the end of the course, but it can be a very big problem. Does that make sense? Managing all these different requirements for all these different products. That's when we get into this discussion on software requirements tools and how they can help. We'll talk a little bit more about that. Okay, RUP, rational unified process, common. Again, this is kind of getting a little bit long in the tooth, meaning it's getting a little bit old. This came out of the UML, initiatives back when Jakobson and Booch and Rumbaugh, all 3 of these guys, all combined their different modeling approaches and that's why they call it unified. There's actually 3 guys that were doing object-oriented development differently. Jakobson was with use cases. Grady Booch and Jim Rumbaugh were doing different types of object-oriented modeling techniques. They all got together, came up with a unified modeling approach, which is now the UML. They also developed a rational unified process. Rational only because that was the name of the company, which is now, of course, IBM. Rational got bought by IBM, so this whole thing is now kind of IBM. That's why I put the R in parentheses. But what can you notice by looking at these different phases of development. You can see if you look up, for example, at requirements, and business modeling is kind of like requirements as well. But what do you notice? It's got a long tail to it, doesn't it? You know, yes, I may do most of it during the inception phase. That's the rough term for requirements analysis. That's the thing. That's the one thing about these guys. They had to come up with different names for all these different phases. They couldn't call it like what everyone else called it. You know, requirements, design, code unit test, deployment. They had to come up with new names. That's how you make money when you're selling your tools. But anyway, requirements, business modeling, both of these is the main focus of this course. Long tails associated with them, which just tells you that requirements is a lifetime activity. And that is true. So we're going to talk about change control boards and things like that, why that's important. But change will occur throughout the process. I'm right now we're going through the initial for that SDK 1.7, what I showed you in that previous picture. We're right about here. We're going through the inception phase, but we're also dealing with requirements changes in other products. Okay, so it's a lifetime phase, and you got to manage it accordingly. And every one of these really is. All this basically just says is, you know what? It makes sense to have increments because a lot of the stuff is going to change. Change is constant. Okay, let's get into a little bit more on actors. Now, you all know, you've probably heard of the term actor, right? Normally, what is actor? When you think of actor, what is that? What do you think of? Use cases? Has anybody not done use cases? Just to go, okay, a couple. We're going to talk about it, so you'll get an update on it. I often find that even the students that say they've heard of use cases, a lot of them don't do it right. So I'll give you just a breakdown of how I want to do it, and it's a pretty lightweight approach. But let's start with actor. First of all, we know that a lot of potential people, we'll start with people, will interact with this system. Some people will operate it. Some people will benefit from it. It's still an actor. The customer is one actor. They're the ones that usually, I have it different than a user. A user is the guy sitting, using the computer, doing whatever. The customer may be the one that funds it, pays for it, markets it, but it's not the user. So they're actually slightly different. Now, if you don't have a user or a customer in-house, that you can talk to, sometimes they're not available. What's the next best thing? You go talk to your marketing guys. The market analysts, sometimes they're called business analysts. These guys are the ones, which is sometimes they're requirements engineers. These are the guys that represent the customer, and they're the ones that are supposed to know enough about the domain and the customer that they tell you. They act on behalf of the customer. They're a customer proxy. And there's some 3 categories of actors you need to know. There's some process actors. Again, actors are groups of, think of them as groups of people that maybe have a vested interest in what you're building, your software. Regulators. So remember I talked about certain products like safety critical products are always going to have, sometimes they're called watchdogs. That's the derogatory term for it. You'll be asked to meet a very strict set of regulations. So in the safety critical, it's going to be the FDA, Food and Drug Administration. If you're building a product for the defense industry, it's going to be one of their agencies. There's companies like MITRE, Lincoln Labs. There's a whole bunch of these companies that all they do is they act as a government regulator. So they'll come into a defense company like here at Raytheon in Dallas, and they'll make sure that they're doing the right thing. And it's not just about answering questions. Sometimes you have to show proof that you are doing what you're supposed to be doing. If you don't have that proof, you won't, get you won't get their permission to proceed. And then of course there's software engineers because they're the ones that not only they're gonna have to take your requirements document and go implement it, but they may also have some other interests too. So let's say the software engineers or the software engineering department is very into reusing components from other products. What happens when you reuse a component? It means you sometimes have to go back and change your requirements because the reused component may not be exactly what you want, right? Here's an example is a real-time operating system, or even pick any operating system. Let's say you have to develop an operating system for your software. You can either write your own, and if you write your own, you'll be able to implement anything you want, exactly the way you like it. But if you choose instead, because you don't have the people to write your own, it's going to take a long time to write your own operating system. If instead you want to go buy a real-time operating system, or in this case, you can actually use a free one. There's some free ones out there. Instead, you can go do that. But what normally, they're not going to be an exact match for the requirements that you want. They may have a little bit too much in some areas, a little bit too little in other areas. And you have to, but it may be worth the benefit to go back and modify some requirements in order to allow you to use this operating system. In my line of work, in my group, the predominant operating system is Linux. We have some real-time operating systems we use as well, but we don't write our own. We always use something that's out there, and that has some impact on how. So if we get a requirement, for example, that is not, quite frankly, consistent with one of our operating systems that we support, we're going to push back on it because we want to reuse those components. It's very important to us that we reuse those components. So this last bullet is mainly dealing with that issue. Okay, now a lot of words here. I won't read this. This is talking about a lot of this is what I just got through saying. So read that. I just got through talking about that. Okay, I want to go on to this next section. We're going to talk about, this is a little bit about management. A couple very quick slides on this. I'm going to quickly move through this section because this is kind of dry. But there is a requirements engineering process. I want to make you familiar with it. Ian Somerville describes it like this. You got to at least assess some feasibility. Normally, before you go do something, you have to know it's even feasible to do. That's why we try to define what the problem is to begin with. We go through that root cause. We try to identify the key issues, and then we may go in and argue feasibility. Now, this can be formal, like in the defense industry. There is actually a document you produce. It's not called the feasibility report. It's something more elaborate, name-sounding, like an operational readiness report or something like that, where you have to basically say, yeah, it makes sense to go do this. It's feasible to go do this. It fits into our strategy. If it passes that phase, and some don't, there's a lot of great ideas out there, but at the end of the day, a lot of those ideas won't get funded. That's just the real world. But if it does, then you start going into elicitation analysis, and we're going to do that next. So this is coming up in the next phase, really. As part of that, you develop system models. Now, we'll spend probably, 2 or 3 class periods talking about models. We're going to be developing all kinds of models. And it's important because it allows you to see the problem from different perspectives, find hidden requirements, gain a better understanding of the problem you're trying to solve by abstracting out the unnecessary details. And so we're going to do a lot of modeling, and then we'll also produce the specification, which is part of your project. This specification, in this class, I'm going to combine this bullet and that, and we're going to have one requirement specification. But we're working our way down this. So feasibility, elicit, model, and that combination is going to produce the requirements. We're going to prioritize them. We're going to validate them, and ultimately form a requirements document. These requirements will be user as well as system requirements. These system requirements in this context is what we were talking about. We were talking about non-functional or quality requirements, requirements that apply to the whole system, like performance, quality, security, things like this. Now, again, because of the section on management, just quickly point out a lot of the management activities. We'll talk about more details of this coming up, but lots of management that has to go into building a product, just a requirements document. As you'll see as we go into some of the elicitation techniques, there's eliciting, there's baselining, managing increments, you have to have at least some input to the project plans, version control, which I just showed you, that multi-version example from one of our customers. This manage relationships between requirements. If you have, for example, this is a consistency comment, if you have 2 or 3 different customers asking for different things, how do you manage all that and prioritize it? I'll give you one example of how you do that. You do what the most important customer tells you to do first. If you have one customer that, like we had Nokia for a customer, they were $1 billion customer. If they told us to do something and a small startup asked us to do something that was inconsistent with that, who do you think we're going to listen to? It's pretty obvious. So you can rate based on the revenue, and there's a lot of techniques. I'll show you some of those. You have to manage traceability and dependency and then status. So lots of activities. We're going to work our way through that as we go through the book. On the analysis side, because we're going to get into this pretty quickly, this domain understanding is what we finished kind of last week, which is just understanding the problem, the domain. Remember we talked about the application domain, the machine domain, the domains of interest. That's kind of why we're doing this. And even then, we'll start collecting some requirements. What were some of the requirements that we're going to collect on those, based on those frame diagrams? Remember what, that's your homework 3, right? 2, 3, 3? Remember we said that every time you identify a connection domain, it immediately set an upper bound on requirements, and it always introduced distortion and delay. Those essentially start to form some of your requirements collection, even that early on. But we're going to do more through elicitation, which I'm going to talk about. Then we'll have to talk about validation, classify. There's a hierarchy we can use, prioritize, and then resolve any conflict. So there's a process that we will follow. And see how these are iterative? See how all these things are iterative? That's there for a reason, because as you go through this, you're going to have to go back to previous steps sometimes and change some things. At the end of validation, eventually what pops out is your document. So you eventually get there, but I've been through projects where the revision on the requirements document was up 10, 11, 12, which meant we've gone through 10, 11, 12 iterations before we finally got it right, because you're getting deeper understanding. And sometimes when you solve one problem, it exposes another problem, so it's an iterative technique. But ultimately what we're going to try to do, and the difference between requirements development and requirements management, is the following. So we're still up here. We're going to start this next phase talking to marketing, to customers, and we're going to gather. That's the whole elicitation. Analyze, we're going to document what we get, review, negotiate with the customer, and eventually at some point we're going to baseline. Now what does baselining requirements mean? Why do we want to baseline requirements? Now at some point it makes sense to, in order to manage change, to just say, you know what, we're close enough, we're going to baseline, which just means there's a couple of ways you can actually implement that. One way would be you establish a configuration management version for that requirements baseline. And what that means is anything beyond that baseline now has to go through a more formal process. So it helps minimize churn. So we're churning, we're discussion, and we're converging, we're getting close. Okay, you know what, we're going to baseline. Now, if you want to make a change, you have to go through a much more painful process, because it helps limit that change, okay? So you have baseline, and all that above the line is requirements development. Below the line is more on the management side. So on the management side, what you have to do oftentimes is you'll take your current baseline, and you're going to go through some change, because we know that things change. We get different the marketing guys came in and said, you know what, customer told me the wrong thing, sorry, we got to do it this way instead of that way. Your customer says, no, I don't really like that prototype, I'd rather have it this way. Management says, sorry, I thought you had 16 months, you only have 12 months. In other words, a constraint. So you get all this stuff coming in. Actually, that constraint would come in from the project side, excuse me. Schedule, money, people. Hey, Rob, sorry, I got to pull 3 of your people off to go work on another high priority project, so now you only have 10 people or something like that. So you get project things, changes coming in, requirements changes coming in, and you're here in the middle. You've got to manage all this. And eventually you've got to put out a revised baseline. What would that revised baseline be? It might be new requirements. It might be changed requirements. It might be deleted requirements because you took my 3 people away and I'm going to de-scope the project. So there's a whole set of activities under here. And this might iterate backwards and forwards often. But now the difference now, as opposed to just some random discussion and who can talk the loudest, now it's formal CCB, change control board, very tightly managed, because now I got to try to get a product out the door, and I can't be listening to your random, now again, for the important things, we'll still do that, but it's got to be a much more disciplined process. Does that make sense, what we're trying to do here, what this is trying to show? So whether that baseline is a formal, you know what, I'm going to move it to another level of configuration management, the requirements document, or something less formal, you should communicate a point at which any further change is going to be managed more aggressively. So this, again, let me just point out a couple expectations of the requirements management. Now, again, requirements management, is it above the line or below the line? It's all that's up below the line, right? The development is up here. The management is now. So these, again, you have to identify. Now, this sounds easy. What do you mean identification of individual requirements? What does that mean? It could just mean, as simple as tagging them with something, an identifier, so that rather than referring to a requirement as this long paragraph, I can just refer to it as R1. So you just tag it. Traceability. I don't think we cover traceability a lot in here. There's a big section on traceability coming up, but basically it means I have to be able to establish some intellectual control between a requirement and its corresponding model, design, test case, power allocation, memory allocation, whatever it is. And I got to have traceability so that if that requirement changes, I can understand the impact on all these other things that are tied to it, okay? So that's really what, I have a whole section on traceability, so I won't talk a lot about it here, but it's a big form of requirements management. As a matter of fact, it's probably one of the biggest focus areas for requirements management. And we'll talk about policies and everything else. And then impact assessment. Someone comes to you and says, hey, I want to make this change. How do you know it doesn't impact a number of other things, right? You take something off the user interface, that could impact all kinds of things all the way through the system, right? So you have to have that impact assessment, which also comes with having good traceability, but it's a form of requirements management. And change control. Normally in a change control board, before you come in with a requirements change, you have to have completed an impact assessment so that everyone that's reviewing your change proposal understands the total impact. Because if you come in and say, oh yeah, the impact assessment is about 12 man-months. In other words, I want to make this requirements change, but it's going to cause 12 man-months of effort with all these other guys. Well, 12 man-months in the US on a fully burdened pay scale is about $200,000. Are you now willing to make that change if it's going to cost $200,000? Okay, it kind of puts all that on the table so you can have a discussion on it. A few other things. Controlled access. What's controlled access to project information mean? Configuration management. In other words, not anybody can get in there and change something. It's controlled. So basic configuration management has to be in place. Now, many configuration management systems, I'm not sure if you guys are familiar with these things, but they're a way of managing version control and change to a product or an artifact. It could be code, could be a document. Normally, it's a shared database, so a lot of your developers have controlled access to that shared database. So that ensures consistency, but also like if you have a global team, many people can access the artifact and work on it, but it's still controlled. So this central repository and shared database helps with that. We talked about change control and tool support. We talk about this at the end. If you look at the SWBOC, it's the one on the farthest right, requirements tools. So I'll defer this discussion to the end, but having a good tool could help you with requirements management. I'm not saying it's a complete cure, but it can help make it a little bit easier for you. So then let's take a quick summary of these requirements management activities. These are the things you might need to know. So it basically involves change control, which we talked about, very important. Version control. It's different than change control. You can have many, many changes that map the different versions of the product you're putting out based on your version policy within your company and product. So how do I manage my versions? It could be as simple as defining a version identification scheme. So right now, my next release of my software development kit is going to be SDK 1.7. Why isn't it 2.0? Why is it 1.7? I'm going to probably put out a patch early next year that's going to be 1.7.1. Well, who came up with that philosophy, that definition? What's a patch release? What's a full release? Well, that's all your version identification scheme. You have to identify what that is, because otherwise you'll confuse your users. I mean, normally, when I go from SDK 1.7, 1.8 to 2.0, that's usually implying a fairly large change in something, right? Linux just did this year and a half, 2 years ago. They went from 2.32, 33, 34 to 3.0. Okay. Now, interestingly enough, Linus Torvalds, the guy who runs Linux, when they kind of asked him what made him decide on 3.0, he said, I thought it was time. So it wasn't really mapped to anything like fundamentally significant, but you would like to have your version scheme defined. So version control, status tracking, where are we on getting all these implemented, tested, what have you, and then tracing them so that if things change, you understand how these trace to test cases and stuff like that. Let me give you another little war story, from my days working in defense. I was on a system integration and test team, and we were flying aircraft out over the Pacific Ocean doing system testing. So we had this product, and we were doing essentially acceptance testing for the customer. And so we created this big test document. We were supposed to go out and rendezvous with some other people out there in the ocean and do these tests. And we had this test plan, and the test plan says we are going to, by going through this test plan, we are going to be able to check off that we validated this number of requirements, right? And this is probably a 12-month exercise. We kept going out. And we went out there, and in this one event that I was on, we went out there. We had our test plan, acceptance test plan. We collected all the data, and we got back. And it wasn't until a day or two later that we realized that because of some traceability between our requirements and our test cases, which was at the time was a manual process, that we collected all the wrong data to help validate those requirements. Okay, no big deal. Just go do it again, right? Well, to do one of these test events, which means to load a bunch of high-priced engineers onto an aircraft, take them out over the ocean, rendezvous with some other people, collect all the data and bring it back. Just to do one of those was $200,000 of taxpayers' money. Okay, so now you go back and you have to tell your customer and your project manager that, oops, we messed up, we didn't have the right test cases, so we collected the wrong data, and we have to go do it all again. $200,000 wasted. Now you start thinking twice about having good traceability, right? Usually that only happens about once or twice before people start getting fired, right? So that's an example of what not to do. So this is very, very important, especially when you have hundreds and hundreds of requirements that you have to validate, maybe with a customer, maybe at system level, maybe even at unit test level. You have to be able to really maintain good traceability. And especially when things are changing all over the place, requirements are coming in, going out, getting deleted, it can be very difficult to do unless you have good tool support and good process to support all that. So that's why that's an important part too. So all these four categories are actually all very important to managing. So now as a requirements engineer, now how do you feel? If you're a manager, software manager, your team may get involved in doing all of this stuff. My team, we do all this. Okay, different people do different parts, but this is all part of what we do to manage software that we ship to customers all over the world. Okay, so we're almost done with this section. Then we're going to move on to elicitation. It starts getting a little bit more fun for tonight. Next week we'll probably start getting into some of the meat of the modeling and stuff. But let's wrap this up. I think just a few words about process quality improvement, just to end up with that section. Now this, we talked about quality already, right? Quality attributes. What did it mean? I said it was another way of saying non-functional requirements. So we're not going to talk about that again. We already talked about that, right? But if you go back to the SWBOC for completeness, that's this section, process quality and improvement. I'll just mention a couple things. It's not easy to align on this because there's a lot of tension between different customers asking for different things. I talked about the trade-offs. So that's usually has to at least be managed. So frequently conflicting, you need to weigh and balance. Here's I put this in there. This is interesting. So what is this? This is what's called a EULA. Have you ever heard that term before? A EULA stands for End User License Agreement, a EULA. You see this on a lot of software these days. Before you can download something, you'll have to go do a click-through license, EULA, and before you can download software. That's the current status of software quality today, is kind of click through this end user license agreement, download it, and you're on your own. We're not guaranteeing anything. We're not going to promise anything. We're not going to tell you this software is never going to fail. Now, if you go off and you buy another product, like, I don't know, this thing, or a phone, or a refrigerator, you do get the warranty, don't you? And it says if this thing fails within 60 days, bring it back, you get a full refund. You'll never see that on a software product, will you? No one will dare put that on a software product, right? It's an interesting thing to think about. Why not? Is our level of quality really that bad that nobody will guarantee their software? Just an interesting rhetorical question, just to think about why not. Even today, we cannot guarantee that. It will never fail. Again, there's some physical, physical properties in refrigerators that don't apply to software, but it's just an interesting discussion topic. This is the current status of software quality. So when you talk about product quality attributes, you have to kind of pick and choose where you want to focus. And again, since we already talked about it, I'm not going to mention it again. You see the same abilities mentioned here, efficiency, usability, et cetera. So I'm just throwing them out there. When you start talking about product quality, I just want you to think, what does that mean to you? Your, again, same things. Your product is going to be different. You're going to be focused on certain things, so just make sure you pick the right things that your customer is interested in. Now, that's product quality. So product quality. Now let's talk about process quality. Now this one you can't as easily escape. Okay? In the commercial world, so like in my world, okay, because software is becoming so important and what we do, and also with a lot of organizations, we get audited, okay? We get audited on how well we define and conform to a process for developing software. Now the one we get conformed to, mainly because we're a commercial company, is ISO. the International Standards Organization. ISO 9000 is a quality management umbrella, and underneath that, there's quality standards that have now been developed for software. Not too long ago, there wasn't one for software. It was for products. And underneath the product audit, there'd be a tiny little section on software. Now there's a dedicated ISO specification 2000 on software. So what does this mean? Again, I'll let you read through I think I've got a picture coming up. I'll let you read through this, but basically what ISO is every 2 years, I get an external team that's not Freescale that comes in, and they spend anywhere from a couple to several days on site, and they look at all of our process documents. They look at our documents that say how we're going to develop software, our requirements documents, our test specifications. They audit the whole, essentially look at everything we say we're doing to develop software, and they confirm that we're conforming to that we're actually doing it, okay? And then they do a write-up. And if you don't do some things right, they'll write up what are called non-conformances. That means this is wrong, you gotta go fix it. And if you don't fix it, it can go all the way up to the CEO of the company, and if you still don't fix it, you can lose your ISO certification, which could be really bad because many companies won't buy from other companies that aren't ISO certified. So it can have an impact on business. So you have to actually, all this stuff I've been talking about, you actually, and will talk about, this stuff is sometimes not optional. You have to, you have to be able to tell an ISO auditor what is your process for gathering requirements, for documenting requirements, for managing requirements. All the requirements development and requirements management stuff that I already talked about. And if you can't show evidence that you're doing it, meaning you can't show them a document with real requirements in it, normally they'll pick a project and they'll say, okay, let's audit this project. And if you can't show them those artifacts, you'll get dinged on that. And that can be a problem if you don't fix it. Sometimes they'll give you 30 days to fix it, or a little bit longer, maybe if you ask for more time. But you will get audited, and you have to fix it. This year, I've got, remember I said I had 6 different sites. I think 3 of those sites have already gotten what are called internal audits, which is a friendly audit. A local internal quality guy from corporate comes over and makes sure that we're not too out of control, so that we won't pass an external audit. So we do some of those every year, but it's a real part of the job, and you have to prepare for an audit, and requirements is a big part of it. External body, again, customers increasingly demanding. They will not buy from a company that's not ISO audited, so it's a really big issue if you don't fix the problems that are found. This is just the how this process rolls out. You define, ISO has a quality model. You take that and you tailor it to your organization. So in other words, it basically gives you some high-level guidelines of what you should do. You then take that and you say, you know what, for Freescale, we're going to develop our quality manual this way, and then we're going to apply that to all of the projects, in Freescale. And then those documents form part of the organizational quality process, and this is what, and then that's what gets audited. It gets instantiated as what comes out of each of these projects, and then this is what gets audited. And if you don't meet that, or you can't demonstrate you're doing that, you get yourself in trouble. Okay, does that make sense? So ISO, think external. If you're a commercial company that develops software, you probably have no choice but to have to go through one of these periodically. And if you're not prepared, and it does take preparation, you may have to explain to management why you got these non-conformances. My quality team, I send them to the different sites. They're really good. I have 2 women that are outstanding at preparing a site for an audit. And so one of them is coming up in China later this year. I'm going to send them over there, and they're going to help prep and get the whole team ready so that when the auditor comes in, they could go smoothly. Okay, so that's ISO. Now, one that's not mandatory, but one that people like to sometimes show off, is the capability maturity model. Has everybody's heard of this? At least heard of it? Anybody not heard of this? CM, capability maturity model? Yes, no, yes, a little bit, okay. So this actually started in the defense industry, where they first recognized that software was so important to defense products that they had to have a way of assessing quality. And so Carnegie Mellon started this thing called the Software Engineering Institute. It's still there today. You can go out there and check it out. They went off and developed the model. Does anybody know the name of the guy? Quiz question, extra credit. The guy who invented the capability maturity model. So his name was Watts Humphrey. He actually came from IBM. He invented this model. He will go down in history as the CMM guy. And it has these 5 levels. And basically, these 5 levels increase in maturity. So if you're at level 1, it says initial. It basically means you're ad hoc. You don't really have any process. And as you go up, I'll show you what these levels mean. As you go up these levels, you're doing more and more things, and from a software engineering perspective, that leads you to a more mature organization. Now, this has always been somewhat controversial. In defense, if you're not at, I think it's level 4 today, you can't even bid on a project. So if you want to go do a project, build a radar system or whatever, and you have all the skills to do it, you think you're the best, but if you can't demonstrate you're at level 4 on the maturity scale, you can't even bid on the contract, okay? In the commercial world, it never caught on for many years. Companies like Microsoft don't do this. Google doesn't follow this, you know. But they're very mature software organizations, so that, you know, okay, well, do you really need it? Sometimes yes, sometimes no. It started catching on. Companies like the cell phone manufacturers, Nokia, Samsung, others, have started asking their suppliers, software suppliers, to demonstrate a level of maturity. In other words, ISO wasn't good enough. They wanted, show me what you're doing on the CMM scale. We still have customers today asking us for this. For you to demonstrate you're at this is a very arduous process. I led a CMMI level 3 effort when I was at Texas Instruments. Just to give you an idea, because you have to show a lot of evidence and what's called institutionalization. What that means is, you don't just show me the artifacts for one project. I'm going to go interview all the people on your project and convince myself that that everything you're doing is institutionalized, that everybody's doing the same thing. And if I can't prove that, I won't get certified. There's hundreds of boxes you have to check to get to each level. So when I took my organization to level 3, it took me almost 2 years just to build up the history, the institutionalization, the artifacts, to convince an auditor that we were doing it across the board, no doubts. So he came into Houston. I was in Houston at the time. And he spent 2 weeks, solid weeks, auditing, checking, interviewing, and then wrote a report that said, okay, you're level 3. 2 weeks. That's 40 hours a week doing nothing but auditing us. Okay, that was just for level 3. Okay. Now, and when you pass a level 3, you get a nice big shingle. You can hang it on the wall. Now the thing is, once you pass the audit, you can degrade right back into chaotic software development. So it doesn't guarantee you're going to suddenly be a great software development organization. It just means that you were able to pass this audit. But people use it as a way of saying, hey, I'm really good. I've lost track of the number of people that have told me that like third parties and people that I want to outsource software to, every one of them, the first thing they said, we're CMMI level 5. But most of the times it doesn't translate into developing good software because they just check boxes. They don't really take it seriously. So you have to be careful with this. But these are what the levels mean. And you can read through this. But and again, what does it mean to from a requirements perspective? Well, it's interesting. so if you look at these levels, let me go back one more. If you view the levels down here, like 2 and 3, as the base, like these are the basic things you need to do to be repeatable and defined. And then these other things up at the top are more, advanced things. So what would be the basic stuff you need to have in place, to do good software development? So think level, by the way, an ISO audit is equivalent to level 2. So level 3 is going a little bit beyond what an ISO audit would give you, okay? So what are those basics? Well, if you go look at this picture, I've broken out some of the key process areas for this. And that level 2, not too surprisingly, requirements management. So what this is saying that, to have just to demonstrate the basics, you have to have good configuration management, quality assurance, you have to be able to manage subcontractors, tracking and oversight, planning, and then management is one of the top, 6. At the defined level, look what you see. Where is it? It's over here. It's going to be under. It's more requirements development. It's under here, integrated software management. But all the requirements is all in the base. It's the basic things you have to do to build upon. Then up here you get into this continuous change, continuous process improvement, things like that. You get much more quantitative. This is TQM, total quality management, and all these advanced techniques are up here. But all the base stuff, it builds a base on good requirements, development and management. So there is a correlation. Like I said, level 2 on the CMM is like an ISO 9000 compliance. So when someone comes to you, so when I got to level 3, that's basically saying this wasn't good enough. I want to show a little bit more maturity in software development, which is level 3 is about where most commercial organizations try to get to. Okay, so again, I went through that quickly, but I wanted to. Okay, so again, the summary here is, process models. There's many of them. The one you choose depends on the kind of software you want to develop and the kind of organization you're in. There's many actors that are to contribute to what we're trying to get done with requirements. There's a lot of management. The two we talked about are basically requirements development, but then requirements management, all those activities, version control, things like this, traceability, those 4 categories. And then we have both product as well as process quality that we have to focus on in order to get that base going. Okay, so any questions on any of this? I think we just talked about this section so far tonight. Over here. So far, so good? Okay, let's start going a little bit into elicitation. What is elicitation? It's kind of this more formal term for basically saying you want to collect requirements. And, collecting, again, that term, it makes it sound so easy. We've already kind of hinted at how hard it can be to collect requirements. And that can be from a user and or a customer or one of many other stakeholders. I identify a few of them early on. So when you hear terms like requirements gathering or just collecting, it kind of gives you the impression that they're just laying around. You just go pick them up, put them into a pile, and you've got your requirements. It's actually a lot more work than that. And if you do it wrong, like we talked about early on in the course, you end up paying for it a lot later on. Okay? There's a lot of forms. I'm going to talk through some of them and give you some examples. But before you can really analyze them, before you can model what you're trying to do, or get clarity on specification or ambiguity, you have to kind of go through a process of eliciting them, gathering them from the many different areas. Some of them, you'll hear me use the term, are hidden. Hidden requirements. What's a hidden requirement? Speaking of gathering, think of looking for Easter eggs. Some are sitting out there in the open, some are hidden. You gotta look harder. Well, we're going to try to talk through some approaches, mainly with modeling, that exposes these hidden requirements, because those hidden requirements can be really important. If you don't get them early, again, we'll pay for it later on, okay? So, I'll start by just introducing, stakeholders. Again, by the way, what's the difference between a stakeholder and an actor? That's interesting. I mentioned actor earlier. I'll come back to that in a second. Think of a stakeholder as a person. An actor can be a person or a thing. And then I'll come back to that and talk about that a little bit later when we talk about use cases. People, primarily, it can represent an organization, but someone that has a valid interest in what you're building. They don't have to be directly impacted by it. In other words, they don't have to actually be like, for example, a user. They can be indirectly impacted by it. Like they can, if you develop an IT system that prints out a report of timesheets, and then that timesheet is reviewed by a manager, that manager is an indirect stakeholder. They're not using the system, but they're benefiting from it in some way. Okay, so people that operate it benefit from it. Even those involved in purchasing it or procuring it. Why is that important? Why are those stakeholders important to the system you're trying to build? Well, let's say you're in the IT business. There's a lot of IT in Dallas. And you're going to procure a new software system. Why are so you're just working in the IT, you're in the IT group. Someone says, there's some new software we got to procure, install. Why are you a very interested stakeholder? Because you're concerned about security, right? You're concerned about install, right? Maybe even resource consumption, like memory and bandwidth and network traffic. So you're actually really concerned about this new. So someone else could be developing the product, and other people could be using it, but you're really interested from an IT perspective in getting the product installed and managed. So, so those guys are important. How about this one? People opposed to the system. Why is this important? Negative stakeholders, people that want to cause malicious harm to your system. There was a section on this. We're going to talk about misuse cases. So why is that? Well, oops. Let me give you an example of, well, first of all, let me ask you, can you think of anybody that could be opposed to a software system? Who might be opposed to a software system? Well, what if the system that's being installed or procured will put a couple of your friends out of work because it automates their job? You might be kind of negative to that whole system, and you might, not go out of your way to learn that system, or you might be quick to talk about all the bad things about the system, right? Really, you can promote it negatively or positively. Sometimes that has a big impact. Managers listen after enough people say bad things. They say, hey, maybe let's go back to the old way. So there's that. Of course, there's the people that may want to, you may cause them to do something differently. Hey, you know what? I've been doing it this way for 20 years, and now you're going to tell me to do it another way. I don't want to do that. The people resist change. Can you think of any time in your careers where technology has changed something and at first you just didn't like it at all? In companies like Freescale, things are changing all the time. Here's an example that got a lot of people upset. A couple years ago, they changed the travel management system. So it changed the whole way we submit expense reports. Supposedly it was going to save the company money, but we had to learn a new way of entering expense reports, which at first was a pain because it took everybody a lot longer to do it. So everybody was complaining about the system, and eventually everyone got used to it. Companies save money, but it's kind of a negative stakeholder. And then of course there's a different class of negative stakeholders that actually want to cause harm to the system. So you have to think about a negative stakeholder as being like a hacker, okay, or someone that wants to cause harm, a denial of service attack, things like this, hacking into the system, trying to do malicious harm to the system. You have to consider those as well. So why do you have to consider those? Because you have to design countermeasures around that so that they can't do that, right? And then organizations responsible for the system because they may have to manage it, do upgrades to it, support it. You buy a product and install it. Is that the end of it? End of the payments? No, you probably have to pay 10% to 20% a year just for maintenance and support and upgrades. So all this has to be considered. So a lot of different kinds of stakeholders. I'm going to throw out a couple of different classes just to give you the sense when you're thinking about it, because one of your homework problems, I'm going to ask you to go think about some stakeholders and stuff, where you could get sources of different inputs from, different classes of stakeholders, okay? Mainly just to get you thinking about this. So government regulation. We talked about a lot of regulatory standards that may come from the government, for example. These are going to drive certain requirements. If you're doing anything with healthcare, HIPAA is very important to you. The healthcare, they're trying to do a lot of things. The Privacy Act, trying to protect our healthcare records and data. So anytime you're managing a business, you have to take that into consideration. When business data, whether it's onshore or offshore, you're going to have to comply to certain government standards. Has anybody ever purchased a gift overseas? There may be some VAT tax applied to that. Sometimes you can get the VAT tax back if you show up at the airport with your receipts. Sometimes not, but there's different VAT rates, different accounting rules, and those change over time. If you have a system that depends on that different VAT rates, your system has to be able to accommodate change. There's going to be some requirements you're going to have to adhere to. So just an example of government. There's industry standards that are going to have, and again, think of these as different places to go look for requirements. Not that they're lying around for you, different places to go look. Industry standards have an impact on your product. Remember earlier tonight when I showed you this picture? I showed you this picture and this femto base station, and I talked about that API, that called it a FAPI, femto API. Well, that's an industry standard, and I didn't have to make up my own API when I was building that software. I was told by my customer, you shall adhere to FAPI version X.X. You can find it on this website. You have to implement that interface. So industry standards are an important part of a place to look for requirements. They have a big impact on performance of some of these products. There's many other examples of this. Standards, the reason you can take money out of any ATM. The fact that when I go overseas in a couple weeks, I'm going to be able to insert my ATM card. It's going to work. Standards, right? Car manufacturers, you get the picture. But a lot of products have standards, and based on the products you're building, many of the products, my team builds networking software. What do you think are the standards there? Well, let's start with the basic one, the ISO 7-layer stack, all right, TCP/IP. That we comply to that standard. But there's many others. There's FAPI interfaces. There's Android API. There's all kinds of standards that you have to understand when you're building your products. You have to look at competitive pressures. It's okay to basically say you got to keep up with it. There's a term called keeping up with the Joneses. You know what that means? That just means keeping up with your competition. So features of competing products. I don't know if I told you my story on this one. But every year I go out to the Embedded Systems Conference. I'm in the embedded space. And several years ago now, we had worked all year to come up with a very interesting addition to our product that allowed someone to build their application, and we would visualize where the linker placed all their data structures and program segments, and we would allow a user to be able to drag and drop these different program segments, and they would automatically update the link control file. And they can help optimize their memory and all this other stuff. It was a great product. And our customers liked it, and we went out to Embedded Systems Conference, and there's vendors all over the showroom floor. And we had our demo set up, and we were the only one of our competition that had this, we called it the visual linker. We were the only one that had this visual linker, available at the time, right? And that conference is held every spring, April, May. So the next year comes by, and I go to the conference like I do every year, and our number one competitor has a visual linker. Now, they called it something else, but it basically did the same thing ours did. Okay? Did we have any recourse? Can we go do anything to them? Not really. I mean, they didn't steal our code. It wasn't patented. Well, not the interface part. So there wasn't any like patent violations. So they went off and they did this. They looked at competitive pressures. They looked at how many potential customers were standing around watching our demos, and they went off and built one. And that's a perfectly legitimate thing to do. Your requirements can come from your competition. Competing products, like it says there, it's sometimes defined the minimal functional requirements. Why is it minimal? Because if you don't keep up with the Joneses, you're not competitive. You have to at least go that far. Normally what you try to do is you try to meet your competitor and then go a little bit beyond. So and it's a big release strategy. A lot of product releases are done in such a way that we can advertise, whether it's marketing or what, but we can advertise we've got more than the competition. So sometimes we'll hold up a release to get in a few extra requirements to be able to claim that. So requirements can be generated anytime the competitor raises the bar, which could occur at any time. This is why things change so often, because no sooner than you get your product out there that one of your competitors is going to have something more. It's a constant battle. When the first bank implemented cash machines, what do you think everyone else had to do? When the airlines went onto the web in a big way, when the first one did it, which I thought was United, I can't remember, everyone else had to follow. It's a constant race to the bottom in some ways. Okay? Information systems projects usually is oftentimes done to promote organizational competitiveness. So lots of competitive pressures. And then, of course, there's market research. We also do this. We do surveys of our users. We talk to them, we survey them, we do market research, what's coming, what's in the research lab, the big thing that everyone is talking about now, and we're doing a lot of market research on now. I don't know if I mentioned this to you. This is what my meeting with last night with that CTO. This is where all the hype is now. Does anybody know what that means? Yeah, Internet of Things. There's different words for it, but Cisco calls it the Internet of Everything. Internet of Things basically means everything is connected. The Internet of Things, And right now, if you search for that, you'll get a gazillion hits on Google. This is almost like, it's not as big as the euphoria that surrounded the web, but it's almost as big for the embedded space because everyone is talking about it, but no one can really define what it is. But we're doing a lot of market research to understand where should we be investing our dollars and requirements into the Internet of Things. Okay. So where do you find the right source? Like I said, they're not easy to find. These categories I just talked about, it's not like someone's going to come to you and say, go look here. Oh, there's a FAPI interface you have to follow. Go do that. Sometimes it's easy. A customer will tell you. Sometimes you have to go, do a little bit more looking. So there's always a discovery phase. And the key is, and this is what comes with experience, knowing when and where to go look for these is pretty critical. Sometimes there's a term called trawling for requirements. You know what a trawler is? I'm almost done, so I'll draw a picture for you because I'm not a very good picture drawer. But I'll try to explain it. So on the water, sometimes there's these boats, right? And these boats, like a fishing boat, sometimes what they try to do is in order to get fish, they'll trawl. They'll throw out a big net. They'll throw out this net, and this net, drags along the bottom, and they'll they try to catch fish this way, right? So, you have these fish swimming around, and the fishing boat's trying to catch the fish. Okay, so that's the challenge. So when you're trawling for fish, what are some of the things that come along with this technique, trawling, or some of the pros and cons? Well, one of them is when you're trawling for fish, you have to know where to trawl, right? If you throw your net down in any random place, you're not going to catch anything, right? Or you're going to catch the wrong stuff. Think of a fish in this discussion being a requirement, okay? So when people go trawling for, I don't know what they trawl, lobsters or whatever, if they're not looking in the right places, how do they know the right places? They have some intelligence. Either it's a fish finder that's saying they're over here, or they know from experience that they go look over here. But if you don't know where to look, you're not going to catch the right fish, or you're not going to get the right requirements, right? Make sense? What else affects this? Well, how about this? How wide is your net? How big is your net? If you have a real small net, you're only going to catch a few requirements, right? If you have a really, really big net, you're going to get a lot of requirements. So you have to, what that means is you've got to cast your net. You've got to look in a broad area. You can't just focus. One of the problems people have is they only look in the areas that they know or that they're comfortable with, and they don't look in the areas that they don't know. And that's wrong, because you're not going to catch all the fish or the requirements, okay? So sometimes you have to get the right people. How about this? You get other stuff. So when I'm trawling, okay, and I'm dragging my net along the bottom, I'm catching fish, but you know what else I'm dragging up? Old boots, rocks, right? Seaweed. When I pull up my net, I'm getting, there's fish in there, but there's all kinds of other stuff, right? Now, what does that mean? That means when you're searching in all these different places, you're going to get a lot of other stuff. In other words, you're going to get people telling you things that either aren't real requirements, or they're incomplete requirements, or it's garbage. It doesn't make sense. You have to, so you'll get some fish, but you're also going to get a bunch of other stuff when you're trawling, right? And then we can throw some other things in here, like it's things like all the other analogies apply. How long, how fast, how long are you looking? How quickly are you? All these things have similar analogies, right? But keep that in mind when you're thinking about getting into this elicitation discussion. And going back over here, kind of knowing when and where is actually a really big problem. It's really important. If you do it right, you'll end up with more of a complete, practical, consistent, correct, and in some cases innovative, requirements and solutions. So this elicitation section we're going to get into is really important, because if it's really the base. If you get junk here, that junk may permeate throughout a lot of the life cycle before you realize it's junk. So I think what we'll do, again, I'll just touch on this and we'll wrap up for today. But there's a lot of elicitation techniques. I think we're actually going to at least touch on all of these, or most of them. We're going to get into some techniques like observation and ethnography. I'll talk about what these are. Some of these are obvious, like questionnaires, interviewing. But interviewing, I got to tell you a few techniques, because a lot of people do this wrong. How to do a brainstorm, how to do a JAD, or a joint application design. well, this is where we'll talk about prototyping, developing pilot systems. I threw in use cases and scenarios as well as misuse cases into this section because it is an elicitation technique. Prototyping, like prototyping a user interface, is an elicitation technique. You're gathering requirements. And then we'll do some risk analysis at the end. So there's a lot of different techniques. Now, when you're, for a particular project you're working on, think of these techniques as tools in your toolbox. You may not use all these techniques for every project. Each of these comes with time and money and effort and cost. So you want to pick the right ones, and I'll give you some guidance on that. But it is an important part. And then we'll get into some of the modeling, which fleshes out some of this in even more detail. Now, the approach we're going to take as we go into this, again, I'll just introduce this. We already kind of have our goals. I mean, we kind of know, we've kind of framed the problem. We kind of know what we're trying to solve, right? Now we're trying to figure out is the details of how we're going to do it. And we know that the end game is going to be some kind of a specification. That's ultimately what we want to do. But how do we get there? Well, the way we're going to get there is we're going to start out with some very user-oriented techniques, which in one word is called elicitation. Why is it user-oriented? Because this is where we're going to spend the majority of our time with the user. So rather than, think of this gray area is the amount of time and effort we're going to spend writing the specification and doing requirements validation. So early on, we're not doing much of that at all. Early on, all we're doing is we're trying to find out which customers to talk to, which techniques, who our customers are. In some cases, we don't even know. Some cases, it's more obvious. Talking to them, getting feedback from them. Very customer, very soft skill oriented, okay? And that's why I mentioned earlier, requirements engineering requires some soft skills to do it effectively. And as we start to gain some stuff from our customers, gain some input, again, I'll talk you through all the details of this next week. We can start documenting some things. We'll start off with maybe a simple operational model. That's where you have context diagrams. You demonstrate the basic understanding of what they're telling you. And then as we get more from our, see how this goes up and down? We may go back to our customers and say, hey, remember when you were telling me about this thing? What did you mean when you said that? Or can you add a little bit more here? And so you're going to go back and forth. And as you go back and forth, and one of these might be, oh, okay, he told me this. That opens up a whole new area. Let's go look over here now so you'll go back and forth. And eventually you'll start developing a specification, we'll do some functional modeling. So we're going to do this. I think we'll get into that next week. We'll start doing some functional models next week where we start understanding more of the internal. So in other words, I hear what you told me in English. I'm going to start modeling it, taking it down to a more mathematical basis, and trying to extract out some hidden requirements, develop our spec. Eventually I end up with a specification that's much more system-oriented. So I'm going towards people, gathering input, tell me, to researching and all that stuff, to writing, validating, prioritizing, and that's the process we're going to follow really over the next, well, actually this whole process will take us all the way up to our midterm, but we're going to get there in steps through the next month or so. That's kind of where we're going. That makes sense? That kind of iterative, see how it's iterative? It's not you talk to a customer once and that's it. Well, most of the times it's going to be an iterative process. Okay, and then now we start getting into the specific techniques, and I'll break there. It's a good stopping point. Any questions on any of the material we talked about tonight? Yeah.
It's about the slide you just showed us. There are some gaps in.
This slide?
Yeah, there are some gaps on the x-axis and y-axis.
Here? Down here?
The starting.
Oh, here?
Yeah.
Yeah, this just means you're going to do a lot of talking before you start writing. You're going to gather input first, and then once you get enough basic understanding, then you'll start writing.
And for the y-axis, there are some gaps.
Yeah, this up here just means that even when you're focused, almost like this would mean even in the last iteration of the requirements document, I probably got my customer involved just for them to say, yeah, that's what I said. You know, yeah, that's what I meant. So they're involved every step of the way, giving some feedback. It's a lot here, it's a little over here, but they're still involved. When I did my last requirements review, I was able to get at least some feedback from the customer that we got it right. So it's little, but it's something. Okay. Any other questions? Okay, I'll probably post another homework or two online, just so if you want to kind of start ahead. I haven't decided on the due dates yet, but I'll post those out there, and I'll also get I'll get caught up on the the grading and such, so you get a chance to get that feedback as well. So all that's that's something I'll work on. If you have any questions on any of the homework, let me know. But I'll start getting those graded. Okay. Any other comments, questions, issues? Comfortable? Yeah. Okay. Well, have a good week. See you next time. Some people ask for my notes. First come, first serve. They're right up there. And I'll see you guys. We'll do it again next week. Thanks a lot.